Hi folks. So in this session we'll do a little more homework D2 help. So I've already recorded a video where I show how to derive a CDF from a PDF from using Microsoft Word's equation editor to kind of make all the notation and math go. But that example was maybe not as complicated to sort of exercise all of the potential challenges you might see, so I thought I'd give you a little more complicated one here. All right, so let's think about a PDF that, say, looks like this. F of x is equal to, and we'll do 0 for x less than or equal to, we'll do -5. Yeah. And then let's do 1.5x plus 7.5 for x, no, sorry, I'll do, that was a little bigger than I wanted it to be. All right, I'm going to rewrite that again. So 1.5 x plus 7.5, and I will do that for -5 for x between -5 and -4. And then we're going to do 0 again for -4 all the way up to 2. And then we'll do 0.5 from 2 to 2.5. And then 0 for x greater than 2.5. And that's the PDF that we want to take care of here. So it would be useful to look at what such a PDF might look like. So I'm just going to draw an axis here. And okay, so we'll just mark this f of x. We're just plotting the density function, and I'm not going to draw this perfectly to scale, but we're just getting the basic idea of what the thing looks like. And so over here, let's say like this is -5, and we'll call this over here, let's say, I'm going to make this a little bigger, again, not to scale, just to give myself enough room, -4, and then we know that the action picks up again at 2, and then picks up again at 2.5. So then we can see what each one of these regions looks like. Well, we know it's 0 for anything before -5. So maybe I'll just draw that a little thicker. Say, let's see how this looks. So we're going to be 0 out here, all the way up to -5. Maybe we'll make that a little thicker. And then what happens at -5? Well, -5, if I plug -5 into f of x, then I can see that f of -5 is going to be 1.5 times -5 plus 7.5. Well, 1.5 times -5, well, half of 5 is 2.5, so 1.5 times -5 is -7.5. So that's just going to be equal to 0. And then if I were to do the other corner of this range, f of -4 then I see that 1.5 times -4 plus 7.5, well, this here is just going to be equal to -6, so that is just going to be equal to 1.5. So basically, I am going to go back to the small pen here, and I'll put 1.5, say, here. I'll call this 1.5. And I know I'm going to need 0.5 later, so maybe I'll put 0.5, say, down here, and I'll call that 0.5. And so I know that at -5, I'm going to be down here. And then at -4, I'm going to be up at this corner. And then I see that it is 0 in between. So then what I'll do is just connect those like so. And then I see it drops down to 0 between -4 and 2. I click that. And then I'm going to then jump. So, I mean, if we want, just to make it, I guess I could put a little maybe dashed lines down here, just so I can see that that's kind of connected there a little bit. And then between 2 and 2.5, I see that, so I'll get rid of this stuff down here. And I see that between 2 and 2.5, so f of 2 to 2.5 is just equal to 0.5. So I know that just like this was 1.5 up here, then I know that this thing here is that, and then it's 0 outside of this range. And then just in case it helps, then maybe I'll put little dashed lines to show there's like kind of a little box here. Okay, so that's our PDF. Now, it would be nice to know that it is a PDF. And so I just would want to say, well, what's the area underneath this curve? Well, if I look back at this curve, I can see that it's basically just the area in this little rectangle here, plus the area in this little triangle here. Well, the area of a triangle is just 1/2 base times height. In this case, it's 1/2. The base it's just 1 wide, and the height is 1.5. So it's just 1.5 over 2, which is equal to 0.75. And over here, I know that this is just, a rectangle, so just base times height. And so the base here is 0.5. The height is 0.5. And so multiply those together, I get 0.25. And as expected, if I add those two areas together, then the total area is going to be 0.75 plus 0.25, which equals 1. And that is exactly what I wanted, right? So, this is a PDF. So you just, trust that we got that right. And so now we just need to say, well, what is the CDF? Okay. So I guess I can leave this here. Maybe this is what I'll do. I was going to leave this little verification that it is a PDF here, and I'm just going to move or copy for now both the spec for this PDF and its graph to a new page here to take a look at. So let's add a page below here, and then we'll paste that in just like before. All right. So now that I've done that, I guess actually I can go back and maybe we can embellish a little bit. So just to make it absolutely clear to everybody, so this triangle here that I kind of drew there, if I were to sort of fill that triangle in, this triangle's total area is 0.75, and this little rectangle's area over here is 0.25. And then so together, the total area is 1. All right. Okay, so we'd like to know what f of x is. Now we know that f of x is just big F of x is just the integral from minus infinity to x underneath little f. And I'm not actually going to use x here. I'm going to use a dummy variable. So I will say put f of u du. And so that's all of the ones we do are going to be equivalent, or going to be basically that right there. So I need to consider a bunch of different cases corresponding to how the PDF is broken up, and then effectively ask, all right, so what is the area up until this particular x? How much area have I added in so far? So if I were to take, let's say, let's do this. I'm going to take this graph here, and let's consider just the case between -5 and -4. So I will copy that, and let's just put together one more little page, and we'll say this here is going to be case, well, technically case 1 is going to be x less than -5. Okay, so let's just do that for practice. And so if I remember my f of x for this up into this case, my f of x is equal to, and all I really care about is everything up to the left of this case. And so it was 0 for x less than -5, and then it was other things for x greater than -5. But we don't actually care too much about those other things because we're only integrating up to that point. So, our question is, what is f of x when x is in this range of x is less than -5? So that is basically, we're asking, what's the integral from -infinity to x when we know that x is less than -5? And so if I were to plug in f of x here, f of u here, du, well, this is just going to be equal to 0. And so the integral of 0 is just going to equal 0. So if I were to put that another way, a graphical way, if I were to paste in that plot that we had from the previous case. So if I would click the right thing here, so if I were to paste in our nice plot here, then for this simple case one, I am asking, so let's say I take an arbitrary point. So maybe I'll put this in a different color. So if I'm taking an arbitrary point here and calling this x, where, remember, this is an arbitrary point where x is less than -5, then the question is, if I'm asking what is f of x, what I'm really asking is what is the area to the left of this x point? How much area do I get under the curve from this point over to the left? Well, it's clear that the area underneath the curve for this point over is equal to 0. So basically, it's as if I could erase, or maybe I won't, it's as if I could erase or cross out, however you want to think about it, everything else that is to the right of this x. And so if, so I could just sort of say, well, actually, I really only care about the graph up to that particular point, and there's absolutely nothing up to that point, and that's why for this particular region, f of x is equal to 0 when x is less than -5. All right, so let's go to a more interesting case. So now I'm going to go to case 2. And that case 2 is when x is between -5 and -4. All right, so if I were to look at the graph for this case, so I'll put that back in. And now consider where we live now in this particular case. Then really what I'm asking is, all right, so I'm going to pick an arbitrary x, where in this case I've got x is between -5 and 4. And so maybe I'll get rid of, this is actually not super convenient to have those here, so I'll erase them. Put that little line back. Okay, so so just to be clear, this particular x is an x that is between -5 and 4 and -4. And so really what I'm asking for is what's the area underneath the curve to the left of this particular point. So if I were to draw a dot up to the PDF, then what I'm really asking is that for this particular f, what is this area right here? I guess I could highlight that. So that is the area that I care about. And so imagine if you took that x and you swept it all the way from -5 to -4, what would the corresponding big F of x look like? So if I were to go down and kind of graph what my guess of this, then I might draw similar looking axes like so. And then so I'm only interested in this region from about -5 to -4. And so for this particular region, I can basically, if I were to draw a line down and say, well, this is the x that I'm interested in here, then what's the, well, I know that for all of these, we've got equal to 0, and then at -5, there's no area underneath that triangle, so that still is 0. But the area underneath this triangle here is, it's effectively going to be 1/2 base times height. Well, if you think about, the base in this case is the distance between x and -5, and the height here is the PDF value. So I mean, if I for this particular case, let's just write down. Let's remember that f of x from that first page, f of x is equal to 1.5x plus 7.5. So I should expect that for this region only, f of x is going to be equal to 1/2 base times height, which is going to be equal to 1/2. And then you say, well, what's my base? Well, the base is the distance from x to -5. So you could do like x minus -5. And then the height is going to be the f of x formula. So that's 1.5x plus 7.5. So this is just little f of x in this region. And this is just, again, the base of the triangle. So triangle base. And then so, this becomes an x plus 5. And so you can kind of imagine if you FOIL all of this stuff out, then you would end up getting a quadratic expression here. And so that will end up looking like something that will look like this. And that's as far as it'll go. So, we don't care about anything to the right of that line. And so when you get finished with this, then you should be able to spot check that that in this particular region, if you did it right, the expression you get will end up being the expression underneath a triangle whose base is this variable x that keeps moving to the right. And so, yeah, you could just FOIL this thing out and you should get exactly the same expression you get out. But we actually want you to do the math. So let's go ahead and do that. So if we wanted to do the math, maybe what we'll do here is I'll just copy if you happen to hear some dog barking, then apologize. There's some commotion with the family pet downstairs. So add page below. Oh no, that's not what we wanted to do. All right, so we're back to case 2, but we're going to kind of try to do it the mathematical way here. And so in the mathematical way we do things, we say that f of x is equal to the integral from -infinity to x of f of u du. Maybe we'll turn off the... Okay, and that is going to be broken up into -infinity to the end of the range, f of u du, plus the end of the range to wherever we currently are in the range, f of u du. And this is just equal to 0. And that 0 that you see right there, so this 0 here is equivalent to the area underneath this portion right here. So we have to add in the area from the previous portions, and that area just happens to be 0. And so then we need to then figure out a formula for this area, and that formula, whatever it will end up being, will, so whatever that ends up being, will end up being the shaded pink area underneath the triangle. So, so that there is going to be because that's equal to 0, I can just maybe get rid of that, and I'll just say it's the integral from -5 to x of, and then I'll just do 1.5 u plus 7.5 du. And so I can say, well, the antiderivative of 1.5u plus 7.5, well, the 1.5u, well, the u is going to go to u squared divided by 2. So this is going to be equal to 1.5 divided by 2 u squared plus 7.5 u, and then that is going to be evaluated from -5 to x. And so that is, so if I think of what's 1.5 divided by 2, that's 0.75 times x squared plus 7.5x, and then minus, and then in here, it's whatever I plug in for -5. So this is 0.75 times, and then this -5 squared is 25, and then plus 7.5 times -5. Well, so that 7.5 times -5 is going to give us a minus, and just if we think about that, 5 times 7 is 35, and then half of 5 is 2.5, so I guess that gives us 37.5 if I did my math right. And then so 0.75 times 25, so that's not the nicest number, so that's 3/4 of 25, or 75 over 4. So rather than me trying to mess that up live, then maybe what we'll do is here is just make sure that we're doing the right math, and there's no harm in that. So that's not what I meant to do. We'll just do this guy. So 7.5. I think I did 7.5 times 5 before, 37.5. That's what we wanted. And then if I go back, 0.75 times 25. So 0.75 times 25 and 1875. Okay. So this right here is 1875. So then finally, if I put all that together, I get 0.75x squared plus 7.5x, and then minus, and this is 1875 minus 37.5, so that's going to give us a negative, so this will turn into a plus. And then if we just do that calculation, 1875 minus 37.5, and we get 1875, which I guess makes sense. So this will be plus 1875. So that is the solution for this piece. So after all of that, f of x for this case is just equal to 0.75 x squared plus 7.5x plus 18.75. And you might think that looks funny because, why are these numbers so large? Because this f of x shouldn't be able to get bigger than 0 to 1. But I think if you think about it, though, you're going to be plugging in numbers for x squared that are between -5 and -4. So right off the bat, we know if we did things right, we should get that f of -5 is equal to 0. And the question is it? So let's just spot check our work. So we can just type that in then. So if I go back to a little calculator, and I do something like, all right, what's 0.75 times 25? And I get that 1875 out, which is what, all right, which we know is going to come back here. So now I just have to do what's 7.5 times negative 5. So if I go back here and do 7.5 times negative 5, then I get minus 37.5. And so it works out. So basically, I end up getting 1875 minus 37.5, right? Plus 1875. And this add together to give me 37.5, and that gives me 0. So this is at least fitting in the range that we want. And if we think about it, this is the same quadratic that as I was kind of expecting. It has this upward shape of this 0.75x squared, like I was expecting from the kind of geometric derivation that we did on the previous page. So over here, I'm kind of expecting this to curve up. And so when we actually do the mathematics for it, it is kind of curving up. So that's our case 2. All right, so let's move on to the other cases. And maybe we can move a little faster. Okay, so for case 3 is another one of those kind of just cases we don't have to worry too much about, but this is between when x is between negative 4 and 2, and f of x is equal to 0 in this particular range. So we know that f of x is equal to the integral from negative infinity to x of f of u du, which now is broken up into minus infinity to negative 5 of f of u du plus the integral from negative 5 to negative 4 of f of u du, and then finally this third integral from negative 4 to x of f of u du. And if I am going with the colors that I was using before, then we know that this portion is the area underneath the curve to the left of negative 5. We know then that this portion is the area underneath the curve between negative 5 and negative 4. And then this new portion is the area underneath the curve between negative 4 and 2, where x is between negative 4 and 2. So we know it should just be obvious that this is going to add 0 regardless of any x in this range. But we could work it out still. I mean, we could write this thing out mathematically and say, well, okay, the yellow portion there, that's just the integral of 0 du, and the little magenta portion here is from negative 5 to negative 4, and I can plug that in, which was the 1.5x plus 7.5. Oh, I'm sorry, when I said x, I meant u. Du, and then plus our new bit, which is just going to be 0 du from negative 2 to x. And so we know that this first bit is 0, this last bit is 0, but notice that this middle portion is definitely not going to be equal to 0. So we've actually done this antiderivative already. It was back on that previous page. So if I go back to that previous page here, and then maybe I'll copy out that antiderivative that we did, which was this portion here. All right, so that is going to be equal to this thing, but the upper bound isn't going to be x anymore. It is going to be negative 4. Okay, so we can then plug in to this antiderivative. Let's just remember that this 1.5 divided by 2 is 0.75, just as a quick reminder. So we can then plug into this the negative 4 and the negative 5, and so we get 0.75 times negative 4 squared plus 7.5 times negative 4 minus 0.75 times negative 5 squared plus 7.5 times negative 5. All right, so 0.75 times negative 4 squared, I could go and say, well, okay, 0.75 times 16, that's negative 4, that's negative 4 squared is 12, plus 7.5 times negative 4, so negative 7.5 times 4 is negative 30. So this 7.5 times negative 4 should actually be minus 30. Minus, and let's see what we've got here, 0.75 times 25, 18.75, which we should remember from before. And then minus 7.5 times 5, 7.5 times 5, 37.5. All right, so what do we get when we put all of that together? Those who are paying attention should have a pretty good guess of what we should get. So 12 minus 30 minus 18.75 plus 37.5. So I guess I may as well just go type that in. 12 minus 30 minus 18.75 plus 37.5. And we get 0.75. And that's exactly what we expected. Why is that exactly what we expected? Because if we remember back in the previous pages here, that the magenta area, that is just the area underneath this triangle, and now we're taking the whole area underneath the triangle. So we may as well go back to the very first page, and that's this green area, which is exactly 0.75. So that is exactly what we were supposed to get. So if you imagine here that what we're doing is we're actually just taking the area underneath the triangle that has negative 5 here and negative 4 here and 1.5 up here. This height is 1.5. The base is 1. So 1/2 base times height is 0.75. And that is exactly what we got through the integral. So good. So for case 3, when x is between negative 4 and 2, we actually have an f of x equal to 0.75. All right, so that is important. This is one of these examples where even though f of x is equal to 0, big F of x is not equal to 0 because it's carrying with it the area that has been integrated up from all the sections before. All right, so now case 4. And that is when we have x between 2 and 2.5. And if you remember, f of x is equal to 0.5 in this region. And so, big F of x in this region is, again, the integral from negative infinity to x of f of u du, which I can actually do a shorthand here, is actually equal to big F of 2 plus the integral from 2 to x of f of u du. Now you see that because if you think about it, what is f of 2? Well, f of 2 is the integral from negative infinity to 2 of f of u du. Well, together, these two integrals are f of x when x is between 2 and 2.5. So rather than me writing out this integral over and over again, I'm just going to do f of 2. And what's nice about that is if I go back to the previous page, I know that when f is in this region, it takes on this form. And so f of 2 is going to be equal to 0.75. I just get that for free. So I can just carry that 0.75 over. So my f of x for this region is going to be equal to 0.75 plus the integral from 2 to x of 0.5 du. And just to make sure everybody is paying attention, this 0.75 corresponds to this one right here. And the rest, this integral here corresponds to this integral here, which is for this particular case that we're working on. And so that is going to be equal to 0.75 plus, and then this will be 0.5 u integrated from 2 to x, which is just equal to 0.75 plus, and this will be 0.5 x minus 0.5 times 2. Well, 0.5 times 2 is just equal to 1. And so, if I look closely here, then this whole thing turns into 0.5 x minus 0.25, where that's 0.75 minus 1 gives me that 0.25. All right, and so this is what we're claiming is f of x in this region. And if we just want to do a spot check, it should be the case that if we plug in f of 2 into this new expression, I should get the same 0.75 out. And so if I plug 2 into this, I get 0.5 times 2 minus 0.25. Well, that equals 0.75. So that's what I wanted. And then if I do f of 2.5, then I get 0.5 times 2.5 minus 0.25. And 0.5 times 2.5 is just going to be equal to 1.25 minus 0.25. That gives me 1. And that's actually what we were expecting. So these just kind of spot checks end up working out. So we have pretty good confidence we've done it right. And so this here is the area of our new region as we sweep through it. And so if I go back to the graphical to sort of try to understand where we are in that plot there, then so maybe I'll grab this one. So this was that previous case that we've been working on. And so now we're in the case where x is between 2 and 2.5. And so the magenta region has already been filled up. And the x that we're working on is some x that's right here. And so we've had no contribution in between here. And so we are currently in this region where we are taking the area of this tiny little rectangle plus all of the area that we've gotten from behind it. And so that's the 0.75 here. And this area of this little rectangle, if I go back to this previous page, that is this expression here. So I guess I could highlight that. So that is 0.5x minus 1. So if you think about what's the area of this little rectangle here, it's going to be x minus 2, which is the base, times the height, which is 0.5. And so if you multiply that through, you get 0.5x minus 1. And so that's just equal to base times height, and that's exactly what we got on that previous page. And so that's how, for this region, f of x is equal to 0.75 plus 0.5x minus 1, where this section is the growing area of the tiny rectangle, and this section is the area of the full triangle. And so if we simplify that, then that's where we got the 0.5x minus 0.25. And that's what we have for this case 4, where x is in that range. Now we're basically done, but we should just double check that we're done, because we do have that fifth case, and the fifth case is just the case here where the density is 0 outside of this region. And so I can, I guess, do that case just to make absolutely sure. So let's add a page below. So case 5 and our final case for this problem, when x is greater than 2.5, we know that f of x, again, integral negative infinity to x of f of u du, which is going to be equal to f of the bottom part of this, 2.5, plus the integral from 2.5 to x f of u du. And we know that this part is equal to 1 just by going to the previous page. And if we plug in f of 1, we get 0.5 times 1 gives me 0.5. I'm sorry, not f of 1, f of 2.5. 0.5 times 2.5 gives me 1.25 minus 0.25, and that, and sure enough, gives me 1. So I go back over, and that gives me 1. So this f of x is going to be equal to 1 plus the integral of 0 du from 2.5 to x, which is, sure enough, just going to be equal to 1. All right, so if we put all of those cases together, then we get this f of x is equal to So we had a case from x less than -5, and so that's 0. We had the case where x was from -5 to -4. And so if I go back to that case, which I wrote up as case 2 here, then I get this 0.75 expression. So if I wanted to, I guess I could just copy this expression here. That's not what I wanted to do. Okay, so that's just from that previous part. And then I say, well, what is it between -4 and 2? Well, if I go back and I look at case 3, it's just equal to a solid 0.75. So I'll go and write in 0.75. And then from 2 to 2.5, I look back at that formula. And so that was case 4. Right here, case 4, and it's equal to 0.5x minus 0.25. And then finally, for x greater than or equal to 2.5, that's case 5, which is right on this page, and that's just equal to 1. And that is my complete CDF, which starts at 0 and rises all the way to 1, where each one of these things is describing the kind of growing area as you're sweeping from the left side all the way across the PDF, integrating under it as you go. All right, so that was kind of a very long way through that, but hopefully that can show you how complicated these examples can get, but how it's just the same pattern over and over and over again.